Well, we need to continue to take our derivatives. Here we're dealing with derivative of, or looking for the derivative of e to the x. You should remember that the derivative of e to the x is still just e to the x because it doesn't change anything. But when you look at the second one here, it's your x raised to a number. Since your exponent's a number, it's just your basic power rule that says put your exponent down in front, decrease your exponent by 1. Well, that's a little bit more of a challenge over here because we have a variable on the bottom, we have a variable in the exponent. So this is where we're going to go back to using logarithmic differentiation. So we're going to apply a natural log to both sides. Then we'll use our properties of logarithms, and we have an exponent after a log, so we'll put that down in front. So we'll rewrite it using our properties of logarithms. Now we'll go ahead and differentiate it. Derivative of the left side, derivative of natural log, is 1 over that. Then remember, multiplied by the derivative of the inside. So the derivative of y with respect to y is y prime or dy over dx, doesn't make a difference. The right side is a product because you're multiplying things together that have variables, so then you have to use a product rule. So in this case, I want the first times the derivative of the second plus the second times the derivative of the first. Well, when you look at that, x times 1 over x, that's just a 1. Then you get 1 times natural log of x, that's just natural log of x. We need to go ahead and get our derivative, which is y prime. We don't want to have a y over there, so get rid of the y by multiplying both sides by y. And well, we do know what y really represents. We know from what we started out with that y was this. So all we have to do is just go ahead and plug in our original, and we get our derivative to be x to the x times 1 plus the natural log of x. Here we need to integrate. Well, remember, if you were looking for the derivative of this, remember your y prime would be still your 2 to the x, but it would be multiplied by the natural log of 2. Now, if you're working backwards, you're still going to have a 2 to the x. Remember, since it's an indefinite integral, you have to have a plus c. But since we're integrating, we'd have to think, okay, if we were doing the chain rule, we'd have this. So you got to think, okay, what would undo that? Well, that's just 1 over our natural log of 2. So that's our integral. Well, here, this is just reviewing our stuff from pre-calc. So here we have our compound interest formula, where P is your initial amount, called your principal, R is your interest rate as a decimal, N is the number of times it's compounded per year, T is the number of years that your money is in the bank. We also have the APERT formula. APERT works whenever it's compounded continuously. Once again, R is still your initial amount, or P is still your initial amount, R is your interest rate as a decimal, and T is your time in years. E is your natural number, E. So we're going to be using those formulas to work out our problem here. So here we're depositing 2,500. Interest rate is 5%, so you're going to use 0.05, and your time is 5. You want to figure out what it is when it's compounded quarterly, monthly, and continuously. Quarterly means your N would be 4. Monthly means it's how many times a year is it compounded? It's at once a month, so that's 12 times. So N would be 12 for part B. So we plug in our 2,500. 1, your interest rate as a decimal. N is 4 because it's quarterly. Raised to the 4 times the number of years, 5. That's your exact answer. You type it in, and you get your decimal approximation. There's your approximation. So we're going to go to 2 decimal points since we're dealing with money. Monthly, the only thing you change up here is your 4 would then become a 12 because it's 12 times a year. Here's your calculator ready form. Right here, you could type it in. If you want to type it in all in one line, you could. Just make sure that if you're typing it in all in one line, your exponent's all in parentheses, or you work out the 12 times 5 in your head. And there's your approximation. And then you're also looking for continuously. Continuously is your APERT formula. So you go your 2500 E raised to the R times your T. So you want to go ahead and type that into your calculator. And then you get your decimal approximation. Notice the more times it's compounded, the more money you make. Well, here we have our bacteria growing at a rate. It's a logistic growth function, which is this here. Now, this is your logistic growth. This is your function. You want to know, okay, what happens for the size of my culture at 0 hours, meaning initially what's the size? What is it after 1 hour, after 10 hours? And then what is it as your time goes off to infinity? Well, all we're going to do is plug in 0 for our t, plug in 0 into our function up here. E to the 0 is 1, and so you get 1 plus a quarter, so you get the same thing top and bottom. So you're starting out with 1 gram. Part B, you're going to put in 1 for your time. So 1 for your time, plug it into your calculator, and you get approximately 1.071 grams. Well, part C, you're going to do the same thing, but not plug in 0 or 1, but plug in 10 because part C is for 10 hours. And you get approximately 1.244 grams. Now, part D up here says, what is your limit as time approaches infinity? In other words, what's our culture going to level out at as time continues on? What's the largest it'll ever get? In other words, you're looking at this here. Now, we're wondering what happens as t gets really, really big. So as we look at this, it's really 1 plus point, oops, got my decimal point in the wrong spot here. Sorry about that. Ignore that one. And it's really e to the negative big number. So let's take a look at e to the negative big and see what that simplifies down to. So if we're just looking at this here, e to the negative big is really 1 over e to the big. 1 over e to the big is really 1 over something really huge, which you know is 0. So in other words, the bottom, top doesn't change. Bottom is really just 1 plus 0. Well, 1 plus 0 doesn't change, or the adding 0 doesn't change it, so it's 120 or 1.25 over 1, which doesn't change it, so it levels out at 1.25 grams.